So we actually have something that is absolutely incredible. A groundbreaking development has emerged as a result of collaborative efforts between student researchers from Google DeepMind and Stanford University. This remarkable creation, known as Mobile ALOHA, stands as an extraordinary robot that provides a glimpse into the exciting possibilities that lie ahead in the near future. First, let's watch the video that was released by one of its founders. Now, let's talk about its founder. So, this is the team. We have Ziping Fu, a Stanford Robotics PhD at Stanford Lab and a student researcher at Google DeepMind. We also have Tony Z, a PhD student at Stanford and a student researcher at Google DeepMind. Additionally, we have Chelsea Finn, CS faculty at Stanford and a research scientist at Google DeepMind. So, these are the people behind this. Now, you'll want to read the abstract, and the abstract essentially serves as the introduction for the research paper. In it, the researchers document how they managed to accomplish everything. Essentially, it begins by stating that imitation learning, where robots observe humans working, proves highly effective for tasks performed on a table, such as picking up objects. However, this is insufficient for tasks requiring movement and the use of the entire body. In this project, a system named Mobile ALOHA was developed, serving as an upgraded version of the older ALOHA system. This new system can move around and is specifically designed to control its entire body, enhancing its versatility. Mobile ALOHA is employed to gather data by mimicking human actions. Subsequently, it is taught to perform tasks independently through a process known as supervised behavior cloning. The learning process is further enhanced using a method called co-training, which will be explored in more detail later in the paper. This involves the system learning from both new and mobile tasks, as well as from the older ALOHA data, which is more static. This approach proves highly effective. By observing and learning from approximately 50 examples of each task, the robot becomes proficient at performing complex actions, such as cooking shrimp, opening cabinets, using an elevator, and washing dishes. In fact, employing this method increases the robot's ability to correctly complete these tasks to up to 90%. Now let's take a look at some of the tasks that they were able to do autonomously. It actually works, but here you can see that this robot is completely going about its day, performing daily tasks on its own. We did see some other examples of this from other robots, like the Palm E demonstration in which there was a robot present. However, I find this one more intriguing because of the way it can perform certain tasks, which we initially thought were only possible with hands. It was able to accomplish many of these tasks, including some, like this one with the chairs, that weren't even in the original data set. By far, this is definitely fascinating stuff. I also remember seeing a video where there was interference with the task, meaning that someone was throwing objects at the robot, yet it still completed the task. A robot being able to cook shrimp at this level is pretty crazy, if you ask me. Some things you need to know about this robot. Firstly, its movement. This robot can move as fast as a person walking. In fact, it can move quite decently. Additionally, it remains steady even when handling heavy objects like pots, showcasing its effective stability. You can control its arms and the base it moves on simultaneously. What's remarkable is that it is self-powered, equipped with its own battery and computer. For the moving part, they chose a mobile base called Tracer, commonly used in warehouses due to its speed, ability to carry heavy loads, and capability to navigate small obstacles and slopes. Moreover, it's more cost-effective than similar products. The robot is designed so that a person can control it by being connected to it. This way, the person can move the robot around while utilizing its arms, particularly helpful for tasks like opening cabinets. It also has cameras on its arms and one in front for seeing, and it can feel and record its movements. As mentioned earlier, this is essentially version 2 of the original Aloha. You can see how accurate this robot is at performing certain tasks, such as inserting a ram stick and using a knife to open a box with precision cuts. It can handle intricate tasks like dealing with bike gears. Even in the teleoperation mode, teleop, where a human controls the robot via another arm, the precision is evident. Teleop mode allows a human to provide input, and the robot replicates the actions. This mode is beneficial as it enables precise control of the robot, showcasing how effective these robots can be with the right dataset or programming. So, this is all about Mobile Aloha. If you want to know more, you can read the papers from the description box. I hope this video was valuable for your time. If you have any queries, you can comment below. Till then, keep learning, keep exploring.